Hello everyone. In today's session, we are going to discuss about VLSM. So in the previous sessions, we have discussed about the introduction about IP address, then classless addressing, classful addressing, okay, and also some problems also we have discussed. So in this session, we are going to discuss about variable length subnet mask. So what is VLSM? So VLSM is variable length subnet mask. So this allows us to create subnets of different sizes from the same network. Instead of giving equal number of IP address to every subnet as in classful addressing, this VLSM allocates IP based on actual requirements. Okay, and also here it avoids wasting of IP addresses, and this also improves the network efficiency. So for an example, if we take HR department, it needs 50 hosts. Lab needs 200 hosts. So admin needs 10 hosts. Okay, so here we can find a new subnet mask for the each network. Okay, and also the IPs will be allocated accordingly. So why VLSM is needed? So it saves IP address space, then it avoids wastage of unused IPs, flexible subnet design, better network performance used in modern networks, CADR classless routing. So the key concept of VLSM is different subnet masks in the same network. So in the same network, we can have different subnet masks for each network. And also largest subnet is allocated first. So first we need to focus only on the largest subnet. Then the next one we can find. Then subnet sizes are calculated using the powers of 2. And also in each subnet has network address, usable host range, then broadcast address. And these are the steps to apply for VLSM. So first of all, we need to identify the main network address. Okay. Then list the number of hosts required for each subnet. Then arrange all the host requirements in descending order, that is larger. So first of all, we need to focus for the larger subnet. Okay. Then calculate subnet size using powers of 2. Then we have to determine the subnet mask for each subnet. Then assign network address, usable IP range, and broadcast address. Repeat for the remaining subnets for the given network. Then advantages of VLSM, efficient IP utilization, scalable network design, reduces routing table size, it supports hierarchical addressing. Okay, now let's discuss a problem using VLSM. So our question is subnet 192, the given IP address is 192.168.10.0. Okay, /24. /24 it is given means it is obviously understood that this belongs to classless addressing. Okay, classless. So subnet this IP to address the network by using the most efficient addressing. So here the diagram it is given. So this is one router. Here also one more. So here it is 20 users. And this is 60. One more. This is also 20 users. Okay, and all these are connected using crossover link. Okay, so totally, so this is the given a large network. Okay, so here this is one network. Let me change. So this is one network. This is second network, and this is third network. And we need to find the crossover link also. Okay, so this is from here to here, and from here to here, and from here to here. So totally 4, 5, and 6. Okay, totally 6 networks are there. Okay. So according to like in VLSM, so this is actually VLSM problem. Okay. So here the first step is we need to find the start with the larger subnet. So here which one is larger subnet we have, and this network, it is for 20 user, and this one is for 60, and this one is for 20. So we need to focus this network 60. Okay. So our first step is to use the 60 users. So our first step is, as usual, subnetting steps, what we have discussed in the previous session. So our first step is the given IP. Okay, so this is the given IP. The given IP is given IP address belongs to which class we need to find. Identify the class of the given IP address. So this given IP address belongs to class C. Then the default subnet mask. Default subnet mask for this class C is what? 255.255.255.0. So our next step is, sorry, our next step is to convert that into binary. So binary means binary format: 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8 dot 1, 2, 3, 4, 5, 6, 7, 8 dot 0, 0, 8. Okay. Now, so our first largest subnet is actually 60. So what is the third step? Number of hosts. Number of hosts required is 60. So we need to find the binary value for the 60. What is the value? Binary value 1111 0 0. So totally how many number of bits? 1, 2, 3, 4, 5, 6 bits. So this is nothing but it is the binary equivalent for this decimal number 60. So how many bits? 6 bits totally. Okay. So now we need to reserve 6 bits at the RHS side. Okay. So thereby we can find the new subnet mask. So now the same 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So six zeros we need to reserve. So 1, 1, remaining 0. Okay. So the first one which we are encountering, that will be the position. That is 2 power 0, 1, 2, 3, 4, 5, 6. So 2 power 6. Now the subnet generator is 2 power 6. The value is 2 power 6 is 64. So a subnet generator value is 64. Next thing we need to find this octet position. So in which octet position we are getting the subnet generator? 1, 2, 3, 4. Fourth position. So octet position is 4. Okay. Now, so now our new subnet mask is 255.255.255. 2 power 6 is 2 power 7. That is 192. Or in slash notation, how can we write? Number of ones. Okay. So number of ones 8, 16, 24, 25, and 26. CIDR notation. So this is the new subnet mask for that particular network. Okay. Next, we are going to write the network ranges. Network ranges. So it starts with 192.168.10.0. Then subnet generator, we need to divide the network into 64. So what will be our next thing? 192.168.10.64. This is first subnet, second subnet. So the first subnet range, this is the first address. Last address I can write 192.168.10.63. So this is going to be the range. So we are going to allocate these IPs for that 60 host for that particular network. Okay. So we are going to allocate the IP address. That is what will be the first address. So this is the network address, and this will be your broadcast address. So first system address, how can we, like, the next address 192.168.10.1, that will be allocated to the first system, first device. Okay. So this range will be allocated for that 60 number of hosts. Now the same way we are going to find for the remaining. Uh, so in this, so here now we have completed this network, and we're going to we are going to find for the other 20 user. Okay. So the other 20 user, next step, second step is 20 user. Same way. So for 20 user, again, we are going to, number of hosts required is now the same steps only. Number of hosts required is 20. So the binary equivalent for this 20 is 10100. Okay, how many number of bits? 1, 2, 3, 4, 5. So 5 bits. Okay, again we have to write. We are going to reserve 5 bits the RHS side. 1, 2, 3, 4, 5, 6, 7, 8 dot 1, 2, 3, 4, 5, 6, 7, 8. 2, 3, 4, 5, 6, 7, 8 dot 5 bits only. So 1, 2, 3, 4, 5, 6, 7, 8. So the first one encoding position 2 power 0, 1, 2, 3, 4, 5. So 2 power 5. Now subnet generator is 2 power 5. The value is 32. Next, we need to find the octet position. Octet position is where we are getting the subnet generator, that position. This is first 1, 2, 3, and this one is fourth. So fourth octet. Now, as usual, we are going to write the network range. So network range, yeah, we can write the new subnet mask also. What is a new subnet mask? So for that particular network, the subnet mask will be used for communication. Okay. Same way, 2 power 5 plus 2 power 6 plus 2 power 7, remaining on 255. So 255 dot 255 dot 255 dot 224. Slash notation, how can we write? The number of ones. 8, 16, 24, 25, 26 and 27. That is CIDR notation. Okay, this is actually new subnet mask. Okay. Now we can write the network ranges. So network range. So network range, how can we write? 30 to 32 we have to subnet. That now we are going to take from the next subnet from this one. Okay. From this will be our first IP. So what is the address now? 192 dot, sorry, 192.168.10.64. From 64, we need to subnet 64. What is the subnet generator we have obtained here? 32. Okay, we are going to divide 32 32 from this IP address. Okay, so what will be our next thing is 96. Next, okay, so the next thing is when we add 32 to the 64, we'll be getting 96. Okay, so now, so this is the subnet range first address, and the last address will be the previous address of this, that is 192.168.10.95. So this is the next range allocated for that 20 user in the given larger network. Okay. Now again in the question, we have completed 60, 20, and one more 20 is there. One more 20, and we need to find the crossover link 1, 2, 3. That is 2 to host. 2 points are there. So 2 to host. Okay. So here we have got this one. That is the next address, next starting address. So for 20 user, again we can write it. Here itself we can write. The next 20, you should add one more 32 with the 96. So we will be getting 128. No. So 192.168.10.127. And this is for another, this will be allocated for another 20 user. This is for 20 user, and this is for another 20 users. Now we are going to find for the crossover link, that is 2 host. Number of hosts required is 2. Totally we have 3, like 3 crossover link. Okay, so for 2 hosts. So number of hosts required is 2. The binary equivalent for 2 is 1, 0. So totally 2 bits. Again, we are going to reserve 2 bits for this one. One, two, three, four, five, six, seven, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So this is the first one is encountering 2 power 0, 2 power 1, 2 power 2. What is your subnet generator? That is 2 power 2 is equal to 4. Subnet generator is 4. What is the octet position? Octet position is also 4. What is our new subnet mask here? New subnet mask is 255.255.255. dot 255 dot 252. So this is the new subnet mask for the host 2. Then we can write the network range. So network range, we should start from the previous one. That is 127. So next thing is 128. So 192.168.10.128. From this IP address, we need to start. 128 next to 2, if you add 132. So 3 crossover links are there, right? So we need to write 10.128 plus 2, 132. Then again, one more, 192.168.10.132 plus 2, 134. So 3 networks for crossover link. 2 crossover links. So the previous address is 192.168.10.131. And here 192.168.10.130. Sure. Sorry, 4, 6, 3, 4. Sorry, 4, 4, right? Sorry. Here we need 136. Sorry, 136. So here it will become 135. Okay. And here 192.168.10.139. That is 140. If we add the other 4, 136 plus 4 is 140. The previous address is 139. Okay. So 4, 4. Subnet address is actually 4 here. So we need that these IP address we can allocate for the two hosts in the crossover link. Okay. Now we have completed for all the given host. Let me write the solution here. Okay. So starting address is 192.168.10.02, 192.168.10.63. Okay. So this is for the first network. And second, 192.160 168.10.64 to 192 192.168.10.95. Okay. Next, 192.168 168.10.96 to 127. Just 2020 host, right? 192.168 10.127. And again, so this is for actually network. This is for 60 users, 20, and this is for 20 users. So all this is for network. Okay. Now crossover link we are going to write 192.168.10.128 192.168.10.130, 131. Next is 192.168.10.132, 132 to 192.168.10.135. Next, 192.168.10.136 to 192.168.10.139. So all this is for 2 to host. 2 to host. That is for crossover link. So this is how we are going to allocate IP addresses for the given larger network. So in VLSM, we will be focusing first on the larger subnet, then same subnetting process we will be using, and we'll at last we will find the network ranges in order to allocate IPs for the given host, given number of hosts. Hope you all have understand this concept. Thank you.